Okay, hi guys. I'm John Ole. Currently, I'm working as a software quality engineer for a health startup company in Vietnam. Besides being a software quality engineer, I'm also a software technical writer, and currently, I'm a community writer in the Solace scholarship program. So I already have one article published in the Solace blog page, which is about how to build an EDA application with Solace. Another article that is about to be published too, which will show the audience how to write contract test for a EDA application using Solace. So for you might not know, EDA stands for event-driven architecture. Um, with Solid, I must say the experience using Solid for the application and for also the articles I have written is very smooth, and I'm very satisfied with Solid. I don't have to worry about the need to set up the event broker server from scratch, like using Apache Kafka. Plus, Solid giving me a lot of flexibilities for defining Solid topics so that I can easily match the application use cases for the Solid topics. Uh, Today, I would like to share with you guys about how we can use Solid to help us build EDA application without hassle and with real-world examples from my two recent articles. So let's jump right in. Uh, First, we will go through the table of contents for the presentation today. Uh, the first thing we will discuss why we need to use event-driven architecture for building applications. Secondly, we will discuss the traditional approach using Apache Kafka as an event broker. Then we will understand what are the problems with using Apache Kafka for the traditional approach and how Solace comes into the picture to address the problems with Kafka. Then we will go through one of my article to how to build an EDA application using Solace so that we can see how Solace fit in for making EDA app pretty easy. Then we will go through another article of me to learn how we can apply contract testing for an EDA app. So maybe some of you guys do not know about contract testing yet. So contract testing is one type of testing that will ensure your different services work well together. So that when you like developing new features of your application, the request and the response format of your services do not break, so that you can safely go on to build new features. The final session would be an Q&A session, so I will be happy to answer some of your questions. All right, so let's jump right in and let's see why we should consider using event-driven architecture for building applications. Um, so yeah, the one benefit of using event-driven architecture is that it helps to improve the responsiveness of our application. It allows the app to respond to certain events in real time. Secondly, it improves the agility for the app. So if you don't use EDA, you need to define your own polling. Let's say on the massive queues like RabbitMQ, and defining your own polling gives you a headache about choosing the suitable polling interval to optimize the action triggering for your app. With EDA app, you can flexibly trigger events through the use of event routers. EDA also helps to decouple services. We all know that coupled services lead to single points of failure, and makes the application hard to scale. Plus, it will hard to recover unexpected incidents occur, such as electrical outages, or we will end up losing connection to databases. So if we have single point of failure, all the services will be down and user will not able to interact with our application at all. So in EDI, the event broker will act as a middleman component. When your application receives user request, the provider service will accept the request, then forward them to the event broker in order. Then the consumer service will tackle each event asynchronously without the running task it's handling. The consumer service will move on to handle other events once the previous event action is done. So with EDI, you can easily scale the producer service, the consumer service, and the event brokers to multiple instances so that your application will be able to handle more requests easily. The final point would be EDI is a push-based approach. So everything happens in demand. The action is only triggered when you have actual requests coming from your customers. So it has your application to cut costs. So that is some of the benefits of using event-driven architecture for making software applications. So let's move on to see the traditional approach of using EDI with Apache Kafka. So with Apache Kafka, you need to manage Apache Kafka instances and need to define your own infrastructure configuration that allows your Kafka to scale in and scale out with different number of user requests. Secondly, you need to poll for Kafka topics. So you need to choose the optimal interval time for your polling. In addition, Kafka topics name are just regular text and lack support for special regex such as asterisk to help you flexibly define your own event consuming. So this will make your application hard to manage if you have a high number of consumers and providers. So I'm giving a little bit spoiler. Solace will provide out-of-the-box hierarchical topic support so that you can flexibly customize your topic setup. The final point is the order of events in Kafka topic is not guaranteed. So you only get events in order by using Kafka partition. So like if you have two consumers subscribe to the same provider, the order of events might be different for these two consumers. So these are problems with traditional approach using Apache Kafka. So let's move on to see how Solace can help. Solace is born to allow us to easily apply EDA for building applications. So it already addressed the issues with Apache Kafka. First thing is you need to manage the event broker instances. Solace will handle them for you. Also, Solace provides scaling parameters, so you can easily scale in and scale out of your event brokers. Secondly, with Solid, events are triggered through the use of event routers. So all you need to do is set your consumer service to listen to the provider service. Then Solace will handle everything for you. You need to set up your own polling handling. The third point is topics in Solace enable hierarchical structure through the use of slash. So the best practice of Solace is to form the topic in a format such as domain slash object type slash verb slash version. So let's say you have a delivery application the topic part of your app would look like deliver slash vehicle type slash action slash version slash the latitude longitude of the location slash vehicle ID slash order ID, and you so a specific order for the given format would be like you have deliver slash drone slash route slash version slash asterisk slash vehicle number ID slash order ID. So you can notice that we have the asterisk in the topic path, which will have you to flexibly custom the topic. Like in this case, the custom the consumer service will accept any path for the asterisk character. So you can like trick in and customize the path that will match with your actual use cases. So that's how we learn how Solace provide features to help us easily apply EDA for our application. Let's move on to see how you can use Solace for a real-world application through one of my recent articles. So one of my articles was written to share with readers how to build an EDA application using the Go programming language and with the Solace PubSub cloud version. The build application has two services, the payment service and notification service. Here, the actor will create a payment request, and then the server will confirm whether the payment API is valid. And if it's valid, the server will send a message to the PubSub cloud broker. The notification service will subscribe to the specific topic in the PubSub cloud broker. So let's say you have the topic that match with the payment ID and using the currency is USD. When you have new event sending to that topic, the notification service will be able to catch that and send notification directly to a Slack channel that the customer service team is on. So they won't miss any missing payment made from. So this is an example API request from user to create a new payment. In this example, we are using Euro currency. Then the server will check whether this payment is valid. If it is valid, the server will make a request to the Solace PubSub broker, and then the notification service will like subscribe to the topic of Solace PubSub cloud, and a notification will be sent to the Slack channel showing a new user has made the payment for a new product with the currency is euro. So to demonstrate the power of Solace topics, let's say we have two types of currencies support for making payments. To allow our application to send notification specifying the different type of currency that the users are using, we can create two different topics. One is for euro, another one is for US dollar. You can notice the topic path for these two topics. We have the asterisk before the euro and the USD part, and also we specify the euro and the USD part in the topic path, so that the notification service will be able to like specify which one come from payment using USD or which one come from payment using euro. So this is the result when we apply the topic path above. The notification will different between using Europe and using USD. So that is my first application made for showcasing how we can use Solace to build an EDA application. Let's go to my second article, which is showcase how we can apply contract testing for a Solace enabled application. So as you may know, software testing is very important in software development, and contract testing is one type of testing to make sure the agreed format of requests and responses among different services are not broken through multiple stages in the development cycle. So through this article, I used facts to apply contract testing, and this is the diagram of the flow in the example app in this article. So here you can see that the example application will have two services, the blogging service app and the notification service. When user create a new blog, the blogging service will send message to the PubSub cloud broker, and then the notification service will actively listen to the Solace topic and will forward the message to the Slack channel when the events are triggered. Here is how you can write the contract from the consumer service. So here you can notice that the contract would expect your request body to have name of the article, first name of the author, last name of the author, and the topic part will match with similar syntax like service slash blog slash author ID slash blog ID slash new. So this is the one. This is the contract we create from the consumer side, and we will then try to test this contract from the provider side. So in the provider side, we will create a sample format of the blog, like first name is Danilo, last name is Nketia, and the name of the article is a great blog. And then we will, at the second step, we will try to make connection to the back platform to back cloud platform to like verify the contract that we already created before, and then finally we verify the contract is met or not by using verify method provided by back tool. So if the test is successful, the provider service will like publish the result to a packed cloud, and you can see here is a successful result between the notification service and the blog service. And And yeah, and that is what I was just went through the how to use Solace to enable EDA applications. So thank you for listening, and hope you have a great experience with Solace and successfully apply Solace for your upcoming projects.